Hello, hello, hello. Am I audible to everyone? Hello, am I audible to everyone? Hello, hello. Am I audible? Is my screen visible to everyone? Hello, let us start today's class. Today we will discuss the application of resistance, and we will take various examples to prove that how Olympiads questions are so easy. Okay, we will take many examples for that, right? Let's consider here each and every case. Suppose that there is a resistance R. Then what is a resistance? Resistance is a property of electrical circuit or a wire, or basically it's an element. It's an electrical element. Property of a resistor is resistance. Resistance is a property of a resistor, right? resistance. Okay. Now here we will carefully see very important point. Resistance basically opposes the flow of charge. Suppose there is a conductor. There is a conductor. There is a conductor. Okay. There is a conductor in which electrons are flowing, right? There is a conductor in which electrons are flowing. First of all, tell me, am I audible to everyone? Is it, my voice is clear or not? Please reply in the chat box. Please reply in the chat box. Please reply in the chat box. Okay. So, suppose there is a conductor. Let's make it more accurate. Look, suppose this is a conductor in which electrons are moving, okay, due to some potential difference. What is potential difference? Potential difference or EMF is basically an electrical action which promotes the flow of charge. Okay. So there are many things which can resist the flow of an electron. For example, other atoms can also resist the flow of electrons. Suppose conductor consists of many atoms. Okay. So these atom will basically resist the flow of electrons, because when the electron will move, it will collide with these atoms and fellow electron. It will collide with these atoms and fellow electrons, and therefore the path will become random, right? Path will become random. Electron will move in random direction, right? And due to these collisions, phenomena of resistance is visible. Due to this, phenomena of resistance is visible. Yes or no? Now you tell me that if phenomena of resistance is visible due to collision of this electron, what will this conductor called? This conductor will called as resistor. Because it contains resistance. Because it contains resistance, it will be called as resistor, right? Now there is a very important application. That if too many resistances are given, okay, and they are connected in series, then what will be the equivalent resistance of all of these resistors, right? What do you mean by equivalent resistance? Equivalent resistance is a simple concept. Basically, it tells you that a single resistor containing a particular resistance can replace all these three and will have same effect as these three resistance are creating, right? So clearly we can say that R equivalent is equal to R1 plus R2 plus R3 if they are connected in series. Now what is series connection? First of all, understand what is series connection. So series connection, in series connection, the resistors are connected. Resistors are connected end to end. Okay. Now, sometime it is very misleading that we will take some questions also, that it would seem that they are connected in, series, but they won't be connected in series, right? It would look like they are connected in series, but they won't be connected in series. In that case, what we will do? In that case, how we identify that whether the resistors are really connected in series? How can we confirm this thing? So we will basically see that if the current in all the resistors are same, irrespective of voltages across them, the current has to be same, because the current wouldn't have any alternative. Current won't have any alternative. So the current will be same in all these resistors. Then we will call it a series resistance, right? You can see here that if the current goes in R1, the same current will go in R2 also. The same current will go in R3 also, because the current has no alternative. Current cannot split from here. Okay. So if the current has no alternative, it simply means that they are connected in series. Here also we can see that if the current has no alternative, if a current is going into R1, it has to go in R2. It cannot go beyond R2, above R2 or below R2, right? So if the current is going in R3, it cannot go above R3 or below R3. It has to go through R3, right? So basically from here we conclude that, resistors are connected end to end. Resistors must be connected end to end, right? So resistors are connected end to end. It's a series connection. Now what about parallel? In parallel connection, the potential difference has to be same. Current may or may not be same. But the potential difference should be same, right? Like in this, whatever the voltage is between A and B, the same voltage is between these 2 points also. The same voltage will be between these 2 points also. So we can notice that if this resistor, and this resistor has same potential difference across them, yes or no? If these resistors have same potential difference across them, we can call it that these are in parallel. These are in parallel, right? So if the resistors are parallel, then the potential difference has to be same. Current may or may not be same. We will take each and every example, right? Okay. Now let us take some examples. Okay. For example, if there is a resistor, suppose there is a resistor 2 ohm and 3 ohm, and these are connected in series. So the R equivalent will be 5 ohms, right? Similarly, if there is a resistance 1 ohm, 2 ohm, 3 ohm, 4 ohm, like this, and if somebody asks me what is the net equivalent resistance between A and B, then it will be how much? It will be R equivalent will be 1 plus 2 plus 3 plus 4. 1 plus 2 plus 3 plus 4. 4, 3, 7, 7, 2, 9, 9 plus 1, it is 10 ohms, right? Similarly, if somebody asks me if these resistors are in parallel, then tell me the equivalent. So what will be the equivalent? 1 by R1 plus 1 by R2 is equal to 1 by R equivalent. It is 1 by 6 plus 1 by 3 is equal to 1 by R equivalent. So its R equivalent will be 6, 1 plus 2, 3, 3 by 6. So R equivalent will become 6 by 3, 12. It's 1 by R equivalent. So it will be 2 ohms, right? Now let us do some questions, and I will give you tricks along the questions, right? As while discussing the questions, I will give you trick. Okay, first of all, a single thing I have to mention, a single trick I have to mention. Please careful. Please be very careful. It's very important. Okay, it's very important. Listen carefully. Listen carefully. Suppose if somebody gives you a resistance R and a resistance 2R by 3, how you will add them? So you will add them like this: R plus 2R by 3. Okay, no issues. No issues. So what you will get? You'll basically get 3 as LCM, and it will become 3R plus 2R. It will become 5R by 3, right? It will become 5R by 3. Okay. Now, I have a better way to do this question. I have a better way to do this question. And the better way is that you should multiply. Notice very carefully. You should multiply this 3 with the coefficient of this one, this R, that is 1. Multiply these two and add this 2. Same thing we are doing here also, but it just make the problem very easy. Okay, very fast. Calculation becomes very fast. Just try to understand what I'm saying. You have to multiply this and add this coefficient, and therefore you can get the answer quickly. So 3 into 1 is 3 plus 2 5, 5R by 3. And let the denominator be in denominator only, and for numerator you have to multiply and then add. For example, if somebody asks you that this is 2R and this is 3R by 2. This is 2R and this is 3R by 2. So what will be the R equivalent? So like as I have already explained you, 2R plus 3R by 2, you have to just multiply these two and add this. 2 into 2 is 4 plus 3 7. So it is 7R by 2. By this the problems become very easy. Problems become very easy by this method, right? Similarly, if somebody asks you that if 4R plus 7R by 2, you have to find R equivalent. So quickly, how you can do that? 4R plus 7R by 2, 7R by 2, you can quickly multiply these two and then add this one, right? So what will be the answer? 4 into 2 is 8 and 8 plus 7 is 15. So it will be 15R by 2, right? So this is a very effective method to do problems very fast, right? Now what I am doing, now let us expand this thing to parallel also. You want some trick for parallel also, and that is what I'm going to deliver right now. For parallel, what you can do, if this is a resistance, suppose it is 2R, and this is a resistance, or let me take some more complicated value, 2R by 3 and R by 4, suppose, and you have to find the R equivalent. So how you will find the R equivalent? How you will find the R equivalent? So there is a formula that 1 by R1 plus 1 by R2 is equal to 1 by R equivalent. We know this thing, right? So what it become? It will become R equivalent is equal to R1 into R2 upon R1 plus R2. We can easily visualize this, right? Now listen carefully. R equivalent is R1 into R2 by R1 plus R2. Now let us just put this in this formula. R1 into R2 is 2R by 3 into R by 4 divided by 2R by 3 plus R by 4. Yes or no? This is the method by which we can do this. Of course, it's a complicated thing, right? Still, we will try to do this. Let us minimize this. Let us put here. Okay. Now again, I start the calculation. Here you can see the value R1 into R2 is R1 plus R2, right? Now what we will do is here we see it becomes 2R square and it becomes 12. So it become R square by 6 and this has become 12 and 3, 4, 4 to 8R it become and plus 4, 3, 3R it becomes, right? It's basic calculation. You must have learned these things in 7th and 8th class, right? So explaining it here, it becomes R square by 6 divided by 11R by 12. 11R by 12. R square by 6 into 12 by 11R. So R get cancelled and it will become 2R by 11. 2R by 11 it will become, right? So basically the result is 2R by 11. This is R equivalent, right? 2R by 11. Now I can solve it orally. How, sir? That is what I'm going to explain you. Let this be 2R by 3 parallel with R by 4. Just understand what I'm saying. You have to multiply the coefficient of the numerator. If there is nothing mentioned, then it must be 1. You have to multiply the coefficients of the numerator and will become 2 and write R as it is. Of course, the answer will contain R also, right? Because all the restances are in terms of R. So the final answer will also contain R, right? And when you cross multiply these two, what you will get? So it will become 8 and 3. And just add 8 plus 3. Cross multiply and then add them. So it will become 11 and put it in the denominator. Here is your answer. I know you want more questions to practice. I will explain them. But for now, you can understand what I'm saying. Just you have to multiply these and then add them and then cross multiply these and add them and then put it in denominator. And for numerator, you have to just multiply the numerator's coefficient, right? Okay. So let's take few more questions. Let's take few more questions. Okay. Let's take few more questions. Suppose I am giving a resistance 4R by 3 parallel with 2R by 5, suppose. And if somebody asks you what is R equivalent, then how to do that? So You don't need to apply any formula. Just you can do like this: 4r by 3 parallel with 2r by 5. You just have to multiply the numerators. It become 8. Write r as it is, and 5 into 4 becomes 20, and 2 into 3 becomes 6. So it becomes 6 plus 20, that is 26. And if you solve it, reduce it, so it will become 4r by 13. That's it. I think it is clear to everyone. 4r by 13. Yes or no? I think it is clear to everyone. Now suppose I am taking some other case. 4r by 5, or let me change the example. 3r by 2 in parallel with 2r by 5. So what it will yield you? 3r by 2 parallel with 2r by 5. First of all, multiply them. It will become 6r. Then 3 into 5 plus 2 into 2. 2 into 2, 4. So it will become 15 plus 4, 19. So it will become 6r by 19. Right? So I think you have got this point. And in the next part of the class, we will discuss questions also. Right? I expect that you revise these things. And then in next class, we will move to the question part. Please go through this class. Please go through this slides so as to make things easily understandable. Thank you so much. That's all.